Right now, India is rapidly expanding its strategic nuclear strike capabilities and steadily increasing its global defense exports. However, persistent delays in domestic fighter jet production are now posing a direct threat to Air Force readiness. This map shows the projected reach of the K-5 submarine-launched ballistic missile, currently being prepared for trials on the S-4 nuclear submarine. The K-5 features a 6,000-kilometer range and carries 6 independent re-entry vehicles, allowing a single launch to strike separate targets. In the air, the Defense Research and Development Organization is currently conducting aerodynamic load studies on the front radome of the Sukhoi 30 MKI to integrate the indigenous Virupaksha radar. This scale illustrates the core engineering challenge. The legacy Russian BARS radar weighs 650 kilograms, while the new indigenous Virupaksha is significantly lighter at 300 kilograms. This requires a complete recalibration of weight distribution and mounting structures to preserve the jet's handling characteristics. While those upgrades proceed, the Tejas Mark 1A program remains stalled. Hindustan Aeronautics Limited has yet to deliver a single aircraft, pushing likely induction to mid-2026, despite having over 20 airframes and 6 F-4 engines currently in inventory. To offset this delayed induction, the Indian Air Force is aggressively stockpiling spare parts to maintain fleet availability for its legacy Mirage 2000 jets. Indigenous sensor development is succeeding on schedule, but persistent assembly line bottlenecks are forcing the Air Force to rely heavily on aging platforms. To fill immediate tactical voids, the military recently completed the maiden flight test of the Terra weapon system, a modular extension kit designed to convert unguided warheads into precision-guided glide bombs. This display details the capabilities of MacFly Aerospace's new Sky Reaper reusable loitering munition. Built for high-altitude deep strikes, the system operates at 10 kilometers with a top speed of 860 kilometers per hour, carrying a 30-kilogram payload. In extreme operational environments like these high-altitude roads in Ladakh, Bajang UAV successfully tested its heavy-lift drone, proving its ability to carry a 30-kilogram payload at an elevation of 16,400 feet. To meet rising military demand for low-cost unmanned strike systems, Thai Defense has expanded its first-person view drone manufacturing capacity to produce roughly 200 units per day. For counter-drone operations, Paris Defense showcased its Ray Strike high-power laser system, offering 3-kilowatt and 9-kilowatt configurations capable of engaging targets from 1.2 to 2.5 kilometers away. India's private defense sector is functioning as a rapid response incubator, successfully delivering the specialized high-altitude and anti-drone technologies the military urgently requires. Internationally, India has fast-tracked a $500 million defense line of credit to Vietnam. This graphic breaks down the allocation, showing $300 million designated strictly for 14 high-speed patrol boats and 4 offshore patrol vessels. The remaining $200 million is allocated for replacing Kilo-class submarine batteries and funding operational upgrades for their Su-30 fighter jets. In the private space sector, Bangalore-based Pixel secured a contract to provide hyperspectral satellite imagery to the United States National Reconnaissance Office. Additionally, DCX Systems and Israel's Elta Systems have begun constructing a new advanced radar manufacturing facility in Tamil Nadu, targeted for completion by April 2027. Through these strategic lines of credit and advanced technology export contracts, India is transitioning its geopolitical position from a primary defense importer to a strategic global supplier. India is successfully reinforcing its strategic deterrence and expanding its global influence through defense exports. However, achieving absolute military self-reliance will require an immediate resolution to the manufacturing bottlenecks stalling its domestic aviation program.